Ayo! So currently, I've got this nice little machine that I'm using, and basically it's called electrical stem, and I am basically electrocuting myself just a little bit right now while I am doing these notes. I have to do this for another 28 minutes, so this is super exciting. It's supposed to help blood flow to my wrist, so they say, but you know. Anyways, title of the notes is Equilibrium, and Reversible Reactions. So today in class we talked about rates of a reaction, how quickly they can happen or how slowly they can happen, and what we can do to increase the temperature, or not increase temperature, but increase the speed of a reaction. We talked about temperature, we talked about concentration, particle size, and the idea of a catalyst. Now, in addition to this chapter being about reaction rates, it's also about this idea of equilibrium. Now, the word equilibrium has equal in it, basically. So I'm just going to highlight. If you have a highlighter, get it out. If you don't, that's fine. I'm going to highlight the word equal in the equilibrium, and I'm just going to point to it, and I'm going to say equal. So by equilibrium, that basically means that there is an equalness, there's an equality, there's a balance. And so I'm going to write, quote, balanced. And equilibrium in terms of chemistry is when the reaction is balanced. So balanced, comma, or both sides, that's reactant and product, have the same amount. So now I'm also going to write at equilibrium, and technically it's chemical equilibrium, the rate, there's that word rate from earlier today, the rate of the forward and reverse reactions is the same. Now, by is the same, I mean same time and same speed, because rate and speed are basically very similar concepts. Now, we have this idea of a forward reaction and a reverse reaction. So you guys keep seeing stuff like this. A goes to B. This is how you've always seen things represented in chemistry in terms of reaction, where A is reactants and B is products. Now, this is what we call a forward reaction. Because it's moving from left to right, and we know this as moving forward. So when the arrow is pointing to the right, that is called a forward reaction. Now, let's say it's the opposite way. It's still A and it's still B, but the arrow is pointing towards A, where A is still the reactant and B is still the product. This is what we would call a reverse reaction, where B goes to A. It's going from right to left instead of going from left to right. So when it's pointing to the left, that is called the reverse reaction. Now, a reaction that's in equilibrium, that basically means that the forward and reverse reactions, that they're equal. So how we would depict that is like so. A and B, and then notice I could draw the forward reaction and the reverse reaction are happening at the same time. Now, instead of writing it like that, the two arrows, scientists usually do a little half arrow that way, and then draw back the other way and do a little half arrow. Add in B. Now that right there, that is my equilibrium arrow. So that is showing that the forward and reverse reaction rates are the same. Okay, so today we took a lot of notes on the idea of rate, how we can speed things up or slow things down. Now we're adding the idea of equilibrium. So equilibrium just means balanced or equal, and if a reaction is in equilibrium, it means that the forward, left to right, and the reverse, right to left, reaction rate is the exact same. And how I would show that is this idea here with this double-headed arrow. This is our equilibrium arrow. It's showing that the forward rate, A going to B, is the same speed and happens at the same exact rate as B going back to A. So this is our equilibrium arrow. So next thing, you're going to need a full page, not a half a page. So flip to the next page. And we are going to title this section Le Chatliers Principle. There's a little hat over the A. Okay? So Le Chatliers Principle has to do with the idea of equilibrium. Okay, this idea of equilibrium. A goes to B and B goes back to A. So Le Chatliers Principle basically states that chemical reactions will shift toward the forward or reverse, so I'm using my arrows, to relieve stress that is placed upon them. And the next thing we're going to do is we're going to set up our notes for tomorrow in class. So I'm going to leave a little space right here, probably 3 lines, and then I'm going to write a reaction. N2 gas plus 2O2 gas plus heat. I'm going to draw my equilibrium arrow, and then I go back the other way. Gives us NO2 gas. The directions are going to say what direction will the reaction shift when each of these stresses occur. So 1, and then I'm skipping lines, 2, 3, all the way down to 8. Skip lines. Okay, for number 1, I'm going to write increase, brackets, N2. I'll tell you tomorrow what the brackets mean. For 2, I'm writing decrease, brackets, O2. Now I'll tell you now. The brackets, they mean concentration or molarity, but I'll remind you guys tomorrow. Number 3, I'm going to write increase concentration of NO2, so that's brackets. Number 4, I'm going to write increase heat. 5, I'm going to write decrease the concentration of NO2, so that's NO2 in brackets. 6, I'm going to write decrease heat. 7, I'm going to write increase pressure. And 8, I'm going to write decrease pressure. And that's it. So we're going to take the rest of the notes tomorrow in class. Have a great evening, guys.